Hey, my name is Leah, and today I'm going to talk about deth and what we're working on, what we've done, and what we're planning to work on in the future. So we're the team of 3 enthusiastic Ethereum developers working on the developer tools because we like the developer experience and want to improve it further. So first, we're going to start with who and why, then tools currently available, then tools in progress and what you can expect, and then some Q&A. Try and be short. So we're currently 3 people. You might recognize us from some contributions on like GitHub and Twitter, working on that. 2 of the people are full-time, and 1 person is joining full-time later this month. Some of the tools that you might know, love, and use from our team are typechain, dethcode, eth-sdk, and Earl.js. And let me just go deeper into each of those tools. So typechain is the TypeScript bindings for the Ethereum smart contract. It generates the types from the ABI and allows you to use the Ethereum smart contracts in a type-safe way. So when you write the tests, you don't make any mistakes. It works with all the major Ethereum libraries like Ethers.js, Web3.js, multiple versions, and it's pretty popular. People use it from multiple protocols. Second tool is pretty recent. It's called dethcode. And what it allows you to do is it allows you to browse the code from Etherscan in the on-the-fly generated VS Code environment. So you can either alter the URL and see the contracts in the IDE, or you can, if you have the browser extension, just click the deth button, and then you can search through the contracts, you can analyze them. Basically, just makes it much easier to read through the contracts from the Etherscan. It also supports multiple chains like Optimism, Arbitrum, all the testnets, and stuff like that. So it's like a small utility that generates a VS Code in your browser and allows you to get familiar with the contract and usually understand what it does. So the third tool is called Ethereum Sdk. And the use case for that is that sometimes you want to interact with some contracts. You're either writing a testing script or testing some strategies, and you want to pull some contracts from Maker, some contracts from Aave, and just have like a library that encapsulates all of those contracts and allows you to integrate with them. So you can do that with this small utility. You just specify the addresses of the contracts on different chains you want to use, and it generates you the libraries. So for those contracts, with all the types, with all those contracts, it pulls the ABIs from Etherscan and all the information that you need to use these contracts, so you can just jump right into development without setting out a lot of stuff. And the fourth one is less connected to the Ethereum, but it will be connected to the Ethereum because it's just an assertion library. It's just a modern type-safe assertion library which supports the snapshot testing, and we use it a lot in our tests and other projects too. And it will soon have the Ethereum plugin, which we'll talk about later. But what in terms of tools that we're currently working on? Because before that, we were kind of working on that after hours and not being very focused on that, but still managed to release some good tools. But now we're putting all our time into that and working on some further developments. So first thing that we're going to be releasing in a couple of days, because it's ready, just the last polishing things, is DeskTools UI. So what we thought during our development experience is that there are a lot of like utility functions and converters and coders, decoders that live in Ethers.js and in other libraries, and they're very useful, but sometimes you just want to have them very handy at hand. So we built the UI with a set of tools to like encode parameters, decode the events, encode constructor arguments, convert hexes to decimals, convert between units, and all this small stuff that you do on the day-to-day basis just on a single page without installing any libraries, so it can work on any computer. The second one is Earl.js Ethereum plugin. So it will be an assertion library which supports Ethereum, so it will be much easier to test for the events, for some reverts, for the formats, the addresses format, the bytes32 format. So it will be the plugin for the aforementioned assertion library that simplifies the Ethereum test writing. And the third one, which today's talk is about, is the Solidity profiler. So Solidity is a very popular language, and it is surprising for me why there is no good Solidity profiler still existing nowadays. Because in Solidity, it is actually much easier to profile stuff than in other language because we have the notion of gas, and we can just measure the gas, and it can be done deterministically. So 4 years ago, I had the same thought, and it was ETH Denver. And we built something like that. So it was a prototype of the Solidity profiler that was just getting the trace and putting that trace back through the source maps and assigning the gas costs to the lines. And we later used that inside of the 0x, but we saw that it wasn't very useful because, as you see on the screenshot, mostly the information that you get here is noise, because mostly you get the information about does this line modify storage or not. And this I can easily figure out without using the profiler, because in the Solidity modifying storage is the most expensive operation. But I think there is a future to that, and we're building that further. So let's see at the problems with that. So first, it shows you mostly the trash, the stuff that didn't change, and that it is the information, it's interesting information, but it's not actionable information. There is nothing you can do with that information. So like if I want to reduce my gas usage, or like this screenshot doesn't help me a lot. But what we think about that is that first we should profile code with the comparison to the previous version of the code based on the PRs. So like you look at the Soulmate repo and there is some magical Remco PRs which optimize some exp function. You should see like where it actually changed stuff and by how much, not how many gas it consumed. And second, you should be able to figure out the like least common denominator of the change. Because imagine you have the Solidity function that used to consume 500 gas and now consume 900 gas. And if you have different objects that you can compare it to. You can profile by the test, you can profile by the contract, by the method, by the call, by the line. So we should figure out like the smallest change that it did in terms of profiling. And for that, you need to figure out the internal calls within the contract. So not only external calls, but also the internal ones, so you can split the gas cost into different methods. Because, for example, if you have method A that called method B and method C, and only the cost of the method C changed, then we don't want to show that method A changed. But the problem there is that the notion of calls only exists, of the internal function calls only exists within the Solidity. It doesn't exist when we compile it to the EVM, because it gets all like linearized to the labels and jumps and all the stuff. But hopefully we were able to deconstruct that using some heuristics and using some source mapping. It will be much better if source maps will be not one-to-one, but one-to-many, but even without that, it was possible to deconstruct. So now, while tracing that, we can deconstruct the whole internal call tree and assign all the gas costs to their proper methods, proper functions. So when you create the PR and you change the gas cost, you can easily pinpoint where did this change come from, how can you address this change, so we can understand it and not only show this like trashy screenshot that's not very actionable, but we can give suggestions. In terms of the timeline for this tool, so like most of the heavy lifting is done. I don't have the screenshots because the UI is not done yet, but the backend is done, and we're planning to release it close to the end of May, the beginning of June. It will be the GitHub action, which will connect to your CI flow and will post the comment on your code, pinpointing the exact places that changed their gas consumption by how much. And then it's up to you to decide if you want to do something about it, but you don't need to wait for the audits to figure out how your code is doing in terms of the performance, in terms of the gas usage. That was all that I wanted to talk about today. Happy to take any questions.
So you said that the profiler, we will be able to incorporate that in the CI. Is that something that we could like make a GitHub action with?
Yep.
Okay. And so will there be, are you guys creating an actual action, or is there something that we'll have to put in our YAML files that's specific to like to call something from a bash or something?
Yeah, the exact integration, I don't know yet, but we'll make it as simple as possible. So when you run your tests, that will be a hard hat plugin initially that will collect the traces, will also collect the artifacts, like send them later for the analysis, and we will publish the comment on the GitHub PR as soon as it's ready. And also you'll be able to click on this comment and see the detailed view in our UI, which will show you exactly which changes happened. Yeah. So that will be a GitHub action, yeah.
Cool.
Thanks for the talk. So I have a question. So as far as I understand that on Optimism and Option, they have different gas model per se, so can you talk about how do you handle that?
Yeah, so initially with the MVP, we obviously support only the Ethereum mainnet. As for the different L2s, some of them reprice opcodes, some of them use different hard forks, some of them differently price the storage or differently price the call data. So obviously all of that will be able to configure in our tool. And in the future, we'll be able to support that. It's nothing like very different. It's just like some changes of constants and different token.
Okay, thank you so much.